Hello. Y'all should have just watched a video kind of directing you on how to do this exponential function thing right here. Make sure you've taken the time to identify the attributes of that exponential function. For an exponential function, the asymptote is always going to be horizontal. So I drew that with this orange line right here so you can kind of see, because this graph, because of the x value here, the graph is never actually going to get all the way to 0. It's going to approach 0. So that's why there's an asymptote there. And then from left to right, the graph is going to go on forever. So our domain is going to be all real numbers. The range, remember, is bottom to top. So the bottom of our graph isn't quite ever going to get to 0. So we're going to say that our range starts at 0. But in interval notation, we use a parenthesis because it doesn't quite get there. It just approaches it. And then the top of the graph is infinity. So our range is going to be from 0 to infinity. X-intercept. Again, we can see that this graph is going to approach the x-axis, but it's never actually going to touch it or cross it. Therefore, there's no x-intercept. The y-intercept to be 0, 1. That's where our graph crosses the y-axis. And then the asymptote is that horizontal line that the graph approaches at y equals 0. Okay, so that's a little review of exponential functions. What I'm going to introduce to y'all now is the logarithmic function. The logarithmic function is actually the inverse of the exponential function. So this is something new you've never seen before. But here's how you write a log function. This is the log. The b is called the base. And then the x, in this case, is called the argument. And that's just some vocabulary for later. To analyze what a log graph looks like, we're going to use log. We would say this as log base 2 of x. Is how you would say that right there, log base 2 of x. And notice this is going to be the inverse function because our exponential function was 2 to the power of x. So now instead of 2 being our base of the exponent, our 2 is going to be the base of the logarithm. Okay, so we can do the same thing we did earlier, is we'll make a little table of x and y values. And because these are inverse functions, we can actually just switch the x and y from the exponential function. So if our first set of x and y values for the exponential function was -2 and +1/4, then for the log function, it's going to be +1/4 for the x value and -2 for the y value. So we can just flip those x and y values to create our table for the logarithm function. You can also graph this in your calculator to get that, but again, I don't have one of those here, so. Okay, so then we've got those points graphed on the grid over here, and we would want to look for, again, that domain range, x-intercept, y-intercept, and if there's any asymptotes. Okay, so for our domain for a log function, that's going to be all of our x values. So we see that this graph is going to go on forever, both up and to the right. And here, our graph is going to approach the y-axis, but it's not actually ever going to touch the y-axis. So this graph is going to keep going like down to -infinity, but it's never actually going to cross the y-axis. So in this case, instead of us having a horizontal asymptote, we're going to have a vertical asymptote.
You're an asymptote.
Stop being an asymptote. Okay, so now we're going to have a vertical asymptote because that's where this graph is going to approach but never actually cross. Kind of a silly memory thing I use. A logarithmic function, you spell it L-O-G. L is a vertical line, so you're always going to have a vertical asymptote with a logarithmic function. I don't know, kind of silly. All right, so for our domain, Our values are never going to go past 0, so our domain is going to go from 0 to positive infinity, and both of those are going to be parentheses because we're never actually going to quite get to 0, and of course we never quite get to infinity. Okay, for the range, that's bottom to top. Our range actually is going to go all the way from negative infinity to positive infinity. So our range would be either all real numbers or negative infinity to positive infinity, however you want to say that. Okay, our x-intercept, that's where our logarithmic function crosses the x-axis. So in this case, our tick units are in halves, so this would be half 1, so our x-intercept is going to be 1, 0. All right, and now the y-intercept is going to be where our graph crosses the y-axis. So again, we kind of follow this down. This is not going to intersect the y-axis because of that vertical asymptote. So for our y-intercept, there's not going to be any because of that vertical asymptote. And then our asymptote, yes, there is. We just discussed that. It's going to be a vertical asymptote. The equation of that vertical asymptote, remember vertical lines have an equation of x equals wherever they cross the y-axis. So it's going to be x equals 0 because at every single point on this axis, the x value there is 0. So our vertical asymptote is going to be x equals 0. Okay. So you're going to watch one more video after this that kind of discusses how these two functions are related. And from there, you should be able to, when you look at a graph, kind of what you'll be responsible for knowing is if you look at a graph, can you tell if it's exponential or logarithmic? And once you've identified if it's exponential or logarithmic, can you find all of those attributes? Can you identify the x-intercept, the y-intercept, and then especially important with these functions are those asymptotes. So identify which kind of function it is, identify those asymptotes, and find those attributes. Okay, have fun graphing. Don't be an asymptote. Do your work, guys. And I hope everybody has a great day.